Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we are going to start the geometry. The geometry in this term, inshallah, divided into two branches. The first part is called trigonometry, and the second part is called geometry or coordinate geometry. In the trigonometry, we have two lessons. It's unit 4, lesson 1 and 2. And the geometry is lesson 5 is unit 5, and it divided into 4 lessons. In the trigonometry we are going to study the triangle, and later I'm going to explain what the meaning of the word trigonometry. But in the geometry we are going which is called coordinate geometry. We are going to study a new type of geometry. It's called coordinate geometry. This geometry depend on the coordinate x-axis and y-axis, and this one used for areas or studying areas and volume and space, study the motion path and so on, and later we are going to explain this ones. Now we have trigonometry. It's unit 4, lesson 1. The lesson today is called the main trigonometrical ratios of acute angle. In this lesson, inshallah, we are going to study new definitions or new symbols called sine, cosine, and tan. And this one we are going to connect the sides of the angle and the sides of triangle and the angles, and we are going to remember the Pythagorean theorem, and we are going to solve many problems about the lesson. Let's start the lesson. First, I need to explain what the meaning of trigonometry. The trigonometry is a branch of mathematics that studies relationships between side length and the angles of triangle, or connect between the side and the angle of triangle. Before we have studied the sides, the triangle according to its sides, and the triangle according to its angles. But today in the trigonometry we are going to connect the sides and the angles, and from the sides we can get the angles, and from the angles we can get the sides. For example, by looking to this building, okay, we divide or we make the shape here a right angle triangle like this, in which the building itself is the side of the right angle, and the distance between the observer and the base of the building is called the base of the triangle, and the distance between the observer and the height of the building is the hypotenuse of this triangle. From this triangle we can study the height, the distance, the angle of elevation, the distance between the observer and the height, and it help many of buildings or towers or bridges, astronomy, suns, planets, stars. This is the using of the trigonometry. Another example, if we have a tower like this tower also divided into right angled triangle, in which the base, the distance between the base and the observer is the base of the right angle triangle. The tower here is the side of the right triangle, and the distance between the observer and the height of the building is the hypotenuse. It's easy by using trigonometry study this triangle to study the height, the distance, the angle of elevation, and everything about this triangle. Let's start our lesson. The lesson, first we are going to study the right angled triangle. Okay, in the right angled triangle, in the trigonometry we also study the right angled triangle, and later inshallah in the secondary we are going to study the trigonometry in the other cases of triangle. Okay, when we have a right angle triangle like this, we know that this one is called the side of the right angle, and this one called side of a right angle, and this one is called the hypotenuse. Again, side of a right angle, side of a right angle, and this one is called the hypotenuse. Okay, now this is the right angle. If we have already two other angles, both of them are acute angles. Okay, by looking to this angle, this symbol is called theta, and theta is a Latin symbol used for angles. Okay, this one is called, as I said, theta. Okay, theta here, by looking to theta, beside theta we have the hypotenuse. Okay, and the side here, this side is called the opposite to this angle theta. Again, theta here. Okay, look to this side, which is called the opposite side. Okay, here beside theta there is another side called the adjacent side. Then, according to theta, I divided the sides of triangle into hypotenuse, adjacent, and theta lie between them, and the third side, which is opposite, is called the opposite to the angle. Okay, if I change theta from this position to this position, what will happen to the sides? First, the hypotenuse is stable, is not change, but this side is called the opposite. This one is the opposite to theta, and this one is the adjacent to theta. Okay, then if we have angle in this position, this is the hypotenuse, the opposite, and the adjacent. Now I make a connection between the angle and the names of the side. The connection will be by using the symbols called trigonometrical ratios. Again, symbols called trigonometrical ratios. The first symbol with us is called sine of the angle, like this. This one is called sine, S-I-N-E, sine of angle theta. What is the sine? This is just a name. Okay, in English it has no meaning, but this is a Latin name. Okay, it has a mathematical meaning. This one is a ratio between two sides. Those two sides are the opposite. It is a ratio between the opposite and the hypotenuse. Then sine of the angle equal the opposite side over the hypotenuse. Okay, another symbol is called cosine of the angle. Again, another symbol called cosine of the angle. What is the cosine of the angle? The cosine also hasn't an English meaning, but it has a mathematical meaning. This is a Latin word. Okay, the cosine is a ratio between the adjacent and the hypotenuse. Then we have the sine of the angle is the opposite over the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse. Okay, finally we have a third one, is called tangent of the angle. Okay, we symbolize this one by tan, T-A-N. Tan of the angle, or tangent of the angle. Tan is a ratio between the opposite and the adjacent. Again, tan is a ratio between the opposite and the adjacent. So we will study later tan by another rule, is sine over cosine. Okay, but here sine is opposite over hypotenuse, cosine adjacent over the hypotenuse, and I explained what is the difference between the adjacent and the opposite, and the tan is the opposite over the adjacent. Now from this ratio, to make it easier for study, I will take S, O, and H from here, and here I will take C, A, and H, and from here I will take T, O, and A, to be like this. So SOHCAHTOA. Read as SOHCAHTOA. SOHCAHTOA. SOH sine opposite hypotenuse. CAH cosine adjacent hypotenuse. TOA tan opposite adjacent. SOHCAHTOA. Okay, it help for studying this ratios. Now I'm going to remember the Pythagorean theorem as we studied before, because we really need this one, because as I said, we study also the right angle triangle. Okay, in the right angle triangle we have here right angle and the two sides here called S, and this one called H. H here is the hypotenuse, S means side, and S means side. If we need to find the hypotenuse equal square root side power of 2 plus side power of 2, and the side equal square root hypotenuse power of 2 minus side power of 2. This is a very, very important rule. Okay, now I'm going to solve the first problem with us. Okay, in this example, in the opposite figure, ABC right angled triangle at B, as we see in the figure. Okay, ABC is a right angled triangle at B, in which AB equal 8 centimeters and AC equal 17 centimeters, and find sine C, tan A, cosine C, tan C, sine A. Okay, sine C, cosine C, tan C are called the trigonometrical ratios for angle C. Okay, and tan A, sine A, and cosine A called trigonometrical ratios of angle A. Okay, now I will start with C, but before I need to find BC. Okay, first I will start with finding BC. BC here is the side of the triangle, then it will be square root 17 power of 2 minus 8 power of 2, it equals 15. So BC equals 15. Okay, now for angle C. This one is called the adjacent, and this one is the opposite. This is the adjacent, this is the adjacent, and this is the opposite. Okay, first sine C. Sine C, as we said before, so ka toa. Sine opposite over hypotenuse, which is equal AB over AC equal 8 over 17, and this is the simplest form for this ratio. Another number 2, cosine C, which is adjacent of the hypotenuse. The adjacent here is 15, then it will be 15 over 17, and tan C, which is opposite over adjacent, it will be AB over BC, which is 8 over 15. Okay, now I will Write the trigonometrical ratios for angle A. Here in angle A, this is the opposite and this is the adjacent. The opposite and this is the adjacent. Okay. Here I will start with sine A. Sine A, sine opposite over hypotenuse, then it will be BC over AC, which is 15 over 17, and this is also the simplest form, and cosine A equal cosine adjacent over hypotenuse, it will be AB over AC equals 8 over 17, and tan A equal tan opposite adjacent, it will be 15 over 8, or BC over AB, it's equal 15 over 8. Now let's solve example 2. Okay, now XYZ is a right angle triangle. In this one we are going to draw by ourselves. Okay, we have here XYZ is right angle triangle at Y. Then I'm going to draw right angle triangle, and the right angle I will call it Y, like this. Okay, right angle triangle like this. The right angle is called Y, and here X and here Z. You can replace the position of X and Z, it's okay, but you can't replace the position of the right angle. Okay, XZ equal 13 centimeters, YZ equal 12 centimeters, and XY is not given. Find number 1, sine X cosine Z times plus cosine X sine Z. Don't forget so ka towa. Okay, number 1, okay, number 1, sine X. Start with X. X sine is opposite over hypotenuse, but before I need to find the third side. Here XY equals square root 13 power of 2 minus 12 power of 2 equals 5 centimeters. Then this one equal 5. Okay, so sine X is opposite over at hypotenuse, it will be 12 over 13 times cosine Z adjacent over hypotenuse, 12 over 13, plus cosine X adjacent over hypotenuse, 5 over 13, sine Z opposite over hypotenuse, also 5 over 13, and you are going to write this one in the calculator. It will be 1. Number 2, cosine x cosine z minus sine x sine z. Okay, cosine x times cosine z minus sine x times sine z. Cosine x adjacent over hypotenuse, which is 5 over 13, and cosine z adjacent over hypotenuse, 12 over 13, and sine x opposite over hypotenuse, 12 over 13, times 5 over 13, which is sine z. Sine z opposite over hypotenuse, 5 over 13. By using the calculator, also this one equal 0. Okay, number 3. One plus tan squared x. Okay, it will be 1 plus tan squared x means tan between brackets, all power of 2 like this. Okay, tan x equal opposite over adjacent. Again, tan equal opposite over adjacent. It will be 12 over 5. By using the calculator, it will be 169 over 25. Example 3. In this example, ABC right angle triangle at B. If 2A equals root 3 AC, find the main trigonometrical ratios of angle C. First, I'm going to draw the triangle like this. Now, the triangle is right at angle B. Okay, here angle B, and here I'm going to write A or C. Okay, what is the meaning of 2A equals root 3C? Now I can't find the length of AB and AC, but I can find the ratio between AB over AC. AB over AC. 2 times AB equal root 3 times AC, then AB takes the ratio, AB takes root 3 and AC takes 2. Okay, then the ratio opposite to AB is root 3, and the ratio opposite to AC is 2. Again, AB opposite to the ratio root 3 and AC opposite to the ratio 2. Okay, then opposite to AB I will write root 3, and the opposite to AC I will write 2. Now, by using the Pythagorean theorem, I will find BC. BC equals square root 2 power of 2 minus root 3 power of 2 equals 1. So BC equals 1. Now the required is find the trigonometrical ratios of angle C. Okay, to find the trigonometrical ratios of angle C, so I need sine C, cosine C, and tan C. Don't forget, so ka toa. Sine C opposite over hypotenuse, which is C here. The opposite is root 3 over the hypotenuse is 2, and this is the simplest form. and cosine C equal cosine equal adjacent over hypotenuse, which is 1 over 2 tan C tan equal opposite over adjacent, which is root 3 over 1. In the simplest form, it will be root 3. Example 4. In the opposite figure, ABC right angle triangle at B, and AB equals 6 centimeters, tan C equal root 3 equals 3 over 4. Okay, number 1, find the length of BC and AC. Okay, I will start with number 1. Okay, since tan C equal 3 over 4, then tan C here, this is the opposite over the adjacent. Okay, then it will be, then AB 6 over BC equals 3 over 4. So BC equal 6 times 4 over 3. 6 times 4, 24 over 3 equals 8. BC equals 8. And to find AC, I will use the Pythagorean Theorem. 8 power of 2 plus 6 power of 2 equals 10. Okay, this is number 1, BC and AC. Number 2, find sine A plus cosine A. Number 2, sine A sine A opposite over hypotenuse 8 over 10 plus cosine A 6 over 10, which is adjacent over hypotenuse, which is equal 14 over 10. In the simplest form is 7 over 5. By looking to this one, we can note here that sine angle plus cosine angle greater than 1. Again, sine angle plus cosine angle, the same angle, is greater than 1. Now we are going to solve example 5. Example 5. ABCD is an isosceles trapezoid in which AD parallel to BC, AD equal 4 centimeters, AB equal 5 centimeters, BC equals 12 centimeters. Prove that 5 tan B cosine C over sine square C plus cosine square B equal 3. Okay, first I need to draw the isosceles trapezoid or isosceles trapezium. It will be like this. In the isosceles trapezium, we have the two legs are equal to each other, and this base parallel to this base. Okay, here AD equal BC. Okay, then I may put AD up and BC down, or the opposite. How can I do this one? Here AD equal 4 centimeters. and AB and BC equals 12 centimeters. Then BC is the base and the lower base, and AD is the upper base. Okay, then here we have BC, and up here we have A to be A, B, C, D. Okay, here we have 4 centimeters, AB equal 5 centimeters, AB equal 5, so CD equal 5. BC equal 12 centimeters. But here we have a problem. Okay, to have tan B or cosine B or sine C, then we need to right angled triangle. So how can we find a right angled triangle? Now I'm going to draw a perpendicular from A and another perpendicular from B to get a right angle triangle like this from A and D together. I can call this one, this is called the construction. I can call this one AE, it's up to you, and I can call this one ADF. Okay, here this one is called left hand side. Okay, so I will write left hand side equal fraction 5 times 10b. 10b in triangle ABE. Okay, ABE triangle in which BE is a base and AE is a height and AB is a hypotenuse. How can I find the other sides? Okay, here we have ADFE is a rectangle, so AD equal 4 and the FE also equal 4. Okay, now in triangle AEB, but before, because this one BC equal 12, so 12 minus 4 equals 8. 8 divided by 2 because BE equal to CF. Why? Because triangle AEB congruent to triangle DFC. Again, triangle ABE congruent to triangle DFC, so BE equal to FC. Okay, 12 minus 4 equal 8. 8 divided by 2 equals 4. Then BE equal 4 and CF also equal 4. Okay, now to find AE equal square root here 5 power of 2 minus 4 power of 2 equals 3 centimeters. So AE equal 3 and also DF equal 3 because AEFD is a rectangle. Okay, back to the left hand side. The left hand side 5 tan B. Tan B, this is angle B. The tan equal opposite over adjacent 3 over 4 times cosine C. Cosine C equal adjacent over hypotenuse, again adjacent over hypotenuse 4 over 5 over sine squared C. Sine C equal opposite over hypotenuse 3 over 5 all to the power of 2 plus cosine squared B. Cosine B adjacent over hypotenuse equals 4 over 5 all to the power of 2. Okay, you can evaluate this one by using calculator or you can simplify, it's up to you. Okay, I will simplify. 4 cancel with 4, okay, and 5 cancel with 5, then the upper equals 3 over 3 over 5 all power of 2 plus 4 over 5 all power of 2 equals 1. 3 over 1 equals 3. So the left hand side equals 3 and the right hand side equals 3. Therefore, the left hand side equals to the right hand side. Now example, I'm going to solve example 6. In this example, ABCD is a trapezoid in which AD parallel to BC and angle B equals 90 degrees. Okay, we have studied in the second prep the right trapezium. The right trapezium is a trapezium in which two of its angles are right, or one of its legs perpendicular to the base, like this. Okay, now we have here right angle like this. Okay, now I need to know which of the two bases is BC and which of them is AD. Okay, here AD equal 6 centimeters and BC equal 10 centimeters. It's easy that here BC, because BC is a bigger base, and here AD. Okay, now I need to write the length on the shape. AB equal 3 centimeters, AD equals 6 centimeters, BC equals 10 centimeters. Okay, as I said before, I have to find right angle triangle. So I will draw a perpendicular from D like this, and I will call this one E, for example. E. Here ABED is a rectangle, so AB equal DE equals 3 centimeters. AD equals 6 and BE also equals 6. Here to find the CE, 10 minus 6 equal 4 centimeters. Okay, now the first step, I will find CD. Equals square root 3 to the power of 2 plus 4 to the power of 2 equals 5 centimeters. Okay, now I have all the sides inside the trapezoid. Okay, he needs to prove that cosine DCB minus tan ACB equals half. Okay, the left hand side equal cosine DCB DCB or angle C. Angle C included in triangle DEC. In this triangle, the adjacent equal 4 and the hypotenuse equal 5. Then it will be 4 over 5 minus tan ACB. ACB. Oh, I need now to connect AC like this to have the right angle triangle ACB. Okay, in this right angle triangle, the opposite this angle, the angle is here like this. In this angle, its opposite is 3 and its adjacent is BC equal 10 centimeters. Then it will be 3 over 10. Here 4 over 5 minus 3 over 10. By using your calculator, it will be half. Therefore, the left hand side equal to the right hand side. Here about 80% from the question depend on the figure. Okay, now I'm going to teach you a new measurement of the angle. Is called circular measurement. Okay, The circular measurement is what? Every unit included its parts from it. For example, we have the length unit. The length unit we included kilometer, and its parts are meter and decimeter and centimeter and so on. If we measure the weight included ton and kilogram and gram and so on. Okay, if we need to measure the angle is its measure is degree. The parts of degree are called minute and second. Let me explain to you what the meaning of minute and second, like this. By looking to this protractor numbered from 0 to 360 degrees. Now, what is the degree? The degree, okay, is a part from 360 part inside the circle. Any circle divided into 360 parts, each part is called degree. Okay, for example, if we have an angle like this angle, its first degree here at 0 and its second degree is at 60, then this angle included 60 degree inside it, so its measure is 60 degrees. We symbolized degree by this circle. Okay, another example. If we have another angle like this angle, its other side or its terminal side is here between 130 and 140, then it is 135. So here an angle included decimal. This decimal may change into the units or the parts of the degree like this. The first part is called minute. Every 1 degree included 60 minutes. We simplified minute by this dash. What is the minute? I can't explain to you what is the minute because the minute is a very, very small unit inside the degree. Here the degree, every dash, very small dash here between every 2 dashes equal 1 degree. We divide the degree into 60 parts. Each part is called minutes. So the degree included 60 minutes. Okay, every minute included 60 parts. Each of them is called second. So 1 degree equal 60 seconds. Okay, 1 minute equal 60 seconds. So 1 degree equals 60 minutes, 1 minute equals 60 seconds. So if I need to measure 1 degree equal how many seconds, then I will multiply 60 times 60 equal 3600 seconds. Okay, it's not our business. Now, how can we change this one into minute and second? For example, if we have 135.5 equal 175 degrees and 30 minutes. How come? By using the calculator like this. Okay, this calculator, I need to change 135.5 degree into minute and second. Okay, I will write 135.5 and this button is called degree minute second. You see here degree minute second. Then I will press this one like this. It appear like this in the screen. So I will press equal. It gives me 135 degrees, 30 minutes and 0 seconds. So it's up to you to write second or not. Then it will be 135 degrees, 30 minutes and 0 seconds. Another example. What can we change? How can we change from minutes, degree, minute, second into degree or into decimal? Like this. I will write 85 degrees here, this button. 37 minutes. Again, the same one. 28 seconds, also the same one. Then I will press equal. Okay, the angle written in the equal. Now I need to change this one into decimal. I will press again degree minute second. It gives me 85 degrees, 0.624, and so on, decimal. Okay, it will be like this: 85 degrees, 0.624. Okay, and this, how can we change from degree to degree minute second, or from degree minute second to degree? This is by using the calculator. Now let's solve problem about this concept. If the ratio between the measures of two supplementary angles, remember with me what the meaning of supplementary. Supplementary means the sum equals 180 degrees. Okay, is 3 to 5. Find the measure of each by degree. Okay, here we can solve this one by many different ways, by equation or by ratio. It's easier to solve by ratio like this: first to second to sum. First is 3 to 5. The sum means 3 plus 5, 8. And here the real sum is 180. It will be like this. So the first equals, by making a cross multiplication like this, 3 times 180 over 8. Over 8. I will teach you how can do it with the calculator again. 3 times 180 over 8 equal, it give me this fraction or a decimal, whatever. So I need to change this one into degree minute second. I will press this button, degree minute second, like this. Then the answer equals 67 degree 30 minutes 0 seconds. 30 67 degrees 30 minutes and 0 second. I will not write 0 second. Number 2, or the second, equals 5 times 180 over 8. It's equal, by using the calculator, it's equal 112 degrees and 30 minutes 0 seconds. The next one, the ratio between two measures of two complementary angles is 3 to 4. Remember, the word complementary means 90 degrees. Okay, find the degree measure of the greater angle in measure. Okay, here first to second to sum, 3 to 4, 3 plus 4, 7, and here I will write 90. Now I need the greater one, which is 4. 4 times 90 over 7. 4 times 90 over 7. And of course we are going to change into degree minute second. It will be 51 degrees 25 minutes and 42 seconds. And this is the end of the lesson. I hope it was helpful for you. See you in the next video إن شاء الله. السلام عليكم ورحمة الله وبركاته. Mr. أحمد محمود was with you.